Welcome to the project demonstration of flexible AC transmission system with thyristor switching project. So here we are going to compensate the power factor with help of thyristor switching. So we are using the thyristor board, and that will get the trigger from the microcontroller. The main application of this project is while we are AC transmission through the loads, whenever we connect the load of inductive load, then the power factor will be varies, that is it will be comes down from 1 to nearby 0.5 or 0.6 or 0.7 based on the inductive load. So why? Because due to the inductive load the current waveforms lags. So whenever the current waveforms lags than the voltage waveform, then the phase difference will be occurred between these two. So the phase difference is called as theta, and when cos theta is a power factor value. So whether it is a leads or lags. Okay, so when we add the inductive load, the power factor will be lags due to this current waveform lags from the voltage waveform, and that will be near to the 0.7, 0.6 based on the load value. And the system will calculate the power factor value with help of current transformer and voltage transformer continuously. Means a microcontroller PIC16F72 will identify the phase difference between the current waveform and voltage waveform from these two sensor modules. So whenever the so-called difference found, then the system will calculate the power factor value with cos theta, and if it is less than the 0.9, as we don't get the 0.1 unity power factor in generally, so that's why we set the limit for the 0.9. So whenever it is less than the 0.9, then the system will on this thyristor to connect the capacitor in parallel to the inductive load. So a capacitive load will leads the current waveform, inductive load will lags the current waveform, so that it will compensate the so-called lagging value, then it will coming near to the voltage waveform, so that the phase difference will be decreases. And when it is near to 0, for example cos 0, as we know that 1, so like that, when the voltage waveform, current waveform phase difference is coming near to 0, then the power factor value will be coming to the near to the 1. So that's why we are using this capacitive load to compensate the power factor. So we are using three major loads. One is the resistive load, which is 100 watts, and the inductive load, which is a 40 watts, and the capacitive load is a 2.5 microfarad capacitive load. So these two are in series. So using this switch, we are going to connect the inductive load in series with the resistive load, and this so-called capacitor was connected in parallel to this R plus L load, and that will be connected through parallel by using this thyristor circuits. And this one is the current transformer waveform output potential divider circuits. So this was input to the A0, A1 for the voltage waveform, as well as B2 to B7 for the 16:2 LCD screen, C7 for this thyristor. So let us see the demonstration. So once we are on the power supply, a welcome message will be displayed on the LCD screen, and the power factor value is 0.92. Right, 0.92 lagging power factor values. The main problem is like when we are demonstrating the project, so we should take care of this plug where we are going to insert this 230 volts AC input. So it may varies from 0.9 to 0.95, a very low difference will be shown here. And when we add the inductive load in series to this resistive load, then the brightness will be decreased, and voltage will be divided between these two loads as they are in series. So it will be restarts, no need to worry about that. Right, so now the power factor value is 0.78 lagging, and the capacitor got added. As we can see, the brightness little bit increased because so-called capacitor got added to this one load. C will be added in parallel to this R plus L loads. And when we isolate this, then we are going to removing the L load from the RLC, right? So when this thyristor got switched on, C will be added to the R plus L load. Now I am isolating that, then the load is going to be R plus C. Then the power factor has to be leading, as capacitive load will lead the current waveform. You can see that 0.91 leading power factor. Right. So once the leading was done, then automatically the thyristor will get switched off, and again it will be compensated to the 0.92 lagging power factor. So when it is above 0.9 power factor, then it's a normal condition. When it is below 0.9 lagging, then the system will on the thyristor to connect the capacitor in parallel to this R plus L load. When it is 0.9 above leading, then the system will isolate the capacitor value to the R plus L load.